Good afternoon, Year 8. Unfortunately, me, Mr. Robson, can't be in at the moment because my wife just gave birth to our third child. So I'm not in today and I'll not be in for your next lesson. But what I'll do is I'll put a video together to make sure you're still making really good progress on what you need to learn. So, today for the Connect activity and the Do Now activity, what we're going to do is we're going to go back to our learning journals and make sure they're spot on. I've looked through quite a few people's learning journals, everyone that's on this group here. There's some people whose learning journal isn't there, so that's a problem because we can't mark it, we can't give any feedback. And there's quite a few people that do not have their binary to denary and denary to binary answers, or their answers from Logic Gate to prove what they got in their assessment. So that's the first thing that we need to do. So we're going to spend about 10 minutes to do that. So on here, a few people need to get sorted is Grace's, yours doesn't work, the link says it's got an error, so can you please make sure you add the correct learning journal on. Kyle, you haven't put your attachment up there, so you need to put it up, otherwise I'll be chasing next week to make sure you get it put up. Charlotte, you have got a link to yours, but when you open it, like it's going to come on the screen here, it's completely blank, so there's nothing we can assess there. So please make sure you find the right file, make sure it's got stuff in, and put it up there. The next thing that quite a few people have, so we'll just look at Jackson's for a second, is they'll have filled the top up. I might have complained if they haven't filled their name and I might put that in pink, or they haven't put capital letters in. So an example here, Jackson needs to fill his details in fully. I've wrote on your baseline percentage you got. As I said, you know, it's not totally, not to worry about, you don't have to compare it with anybody else. And I've put your target for the end of year 8 as a GCSE grade, because now grades are done 1 to 9. So here, looking at Jackson's, he should have put a screenshot of the email he got. So if he's on a PC, he needs the print screen key in the top right of the keyboard. If he's on a Chromebook, he should know how to screenshot and put that score in. If he got less than 80%, he should have really took it again and put a second screenshot in. So for Jackson, quite a few people, binary to denary, there's no evidence, and denary to binary, even though they've done that, there's no evidence that you need to go back and do that. Logic Gate, so if you get that finished, just make sure Logic Gates are labelled. This is really good. So Jackson's labelled his Logic Gates. Jackson needs to put a full stop there, and obviously a truth table, just make sure they're completed as well. And Jackson looks like he's made a pretty decent job of doing his Logic Gates and his truth tables. So the first 10 minutes, and I'm going to ask Sir or Mr. pause the video in a second, is just to make sure your learning journals are there, so that this week, as part of when I'm off, I'll look at your learning journals and I'll give you a little bit of feedback. So if Miss or Sir could pause the video, when they've finished that, we'll go through what we're going to do for today's lesson. Thank you. Okay, so we've looked at how computers represent numbers using binary, and we've done a little bit of conversion from denary to binary. We've looked at computers can also sometimes use hex for numbers, very complicated numbers, like we said about colours, and sort of examples where you need lots and lots of different like large numbers, and we use hex for that because a computer can very easily convert hex into binary. It finds converting denary into binary a little bit more challenging. So today's lesson is all about, well, how do we get computers to represent numbers, letters. So originally computers were basically built to do lots and lots like maths, lots of number crunching, lots of repetitive tasks that dealt with numbers. So what I want you to do is think about this. How does a computer recognize text? Because we know that a computer actually only really sees numbers. So turn to the person next to you, and give you 2 minutes think time. You need to think about how can a computer actually recognize text and therefore display text on the screen or even print text. So what does it use to represent each letter in the alphabet? Once you've done that, think about, well, is it only the letters of the alphabet we need a computer to be able to recognize? What else does it need to be able to recognize that might not be a letter from A to Z? How could it do that? And also, does it make a difference about uppercase and lowercase letters? Because again, the computer can't really understand what they are, but it needs some way of saying that's a capital A and that is a lowercase a. So the person next to you discuss all of those questions. Again, Sarah and Miss should pause the video, and then when they're finished they can press play for the rest of the lesson. Okay, so I'm going to skip the connect because I'm not there. So today's lesson is to recall the purpose and call ASCII. So what people did was they looked at the idea that computers could represent numbers, and I thought, well, that's useful, but we don't talk in numbers, we talk in letters. So somebody in America, and that's what ASCII stands for, American Standard Character Information Interchange, decided we need letters from A to Z and other things, question marks, full stops, commas, and other things which use some punctuation from English. And also spaces, which we'll talk about in a second. So someone designed the ASCII system, which contains 120 character set, so it's got 127 possible different letters or symbols that it can show. We're going to look at how to recognize computer stored letters and numbers. At the moment, when you're in year 8, it's just understanding that actually the computer doesn't see the letter A or the letter B or capital yet. What you've got to learn is basically that the computer sees that as a binary pattern. But to make it easier for us as human beings, we're just going to think about the computer can see numbers, and those numbers are converted to binary. And lastly, we might get onto what Unicode is. That if you kind of finish all the tasks, that's really the extension. So ASCII was the original, and then somebody came along and said, okay, we need Unicode, which is bigger. But you're going to maybe find out later, if you get an extension, why do we need Unicode? Because, you know, with A to Z, that's only 26. Uppercase and lowercase, it's only 52. So really, if we've got 127 combinations, why would we need something that's got even more possible characters in what's called a character set? So basically, the answer is that each letter of the alphabet is represented by a number, and the uppercase number and the lowercase number